Hello friends, greetings to all. I, Prof.Darshan Thakur from Terna Engineering College, welcomes you on my YouTube channel for this subject in network theory. So friends, as far as our today's session is concerned, so in this session, we will try to learn how to tabulate the admittance parameters or the short circuited parameters, or we can call it as a Y parameters of given two port network. So with the help of this example, basically we are supposed to learn how to determine the admittance parameter or the Y parameters of that given network. So before tabulating this Y parameter, one more time we need to recall certain basic things belongs to this two port network. If it is the desired two port network which consists of these two ports, input and output, and these are the parameters of these two ports: input voltage, input current, output voltage and output current. So basically this is how this two port network will look like. So first of all we need to recall the system equation. So in case of this Y parameter as compared to the Z parameter, the two different currents are the dependent variables and the voltages are nothing but independent variables. So accordingly the system equations are nothing but I1 equals to Y11 times of V1 plus Y12 times of V2, and I2 equals to Y21 times of V1 plus Y22 times of V2. So these two are the system equations in which the dependent variables are I1 and I2. As I told you earlier, another name given to this admittance parameter is nothing but what? The short circuited parameters. Because as far as these two system equations are concerned, these two system equations are being written for I1 and I2, and at the same time if we are substituting these two independent variables equals to 0, these two independent variables V1 and V2, then only V2 can determine the different parameters of that admittance matrix. Because admittance matrix is like this, which consists of these four parameters: Y11, Y12, Y21 and Y22. And this admittance is nothing but what? The reciprocal of impedance. So Y equals to what? How that impedance is being defined? Z equals to V by R. So the reciprocal of Z is nothing but what? Y. So it exactly equals to I by V. So this is how the basic structure of that admittance parameter will look like. So what will happen when we equate this V2 equals to 0 and V1 equals to 0? So this equation 1 will become, when V2 equals to 0, I1 equals to Y11 times of V1, and I2 will become, when V2 equals to 0, Y21 times of V1. If we rearrange these equations in terms of Y11 and Y21, so it will become Y11 equals to I1 upon V1 and Y21 equals to I2 upon V1. So this is how these first two admittance parameters are to be determined, which are nothing but what? Y11 equals to I by V. Y21 is again what it is? I by V. The ratio of I by V is nothing but what? The admittance, the reciprocal of impedance. Here Y11 equals to I1 upon V1. Both these two parameters belongs to port number 1. That's why this parameter can be called it as a short circuited driving point input admittance, because it is the ratio of I1 to the V1. Both these two parameters belongs to port number 1. When V2 equals to 0 means what? That can be called it as a short circuited, right? Driving point. Why it is being called it as a driving point? Because both these two parameters belongs to same port. That's why it is being called it as a driving point input admittance. As we are having I1 and V1, both these two parameters belongs to port number 1. Similarly, here Y21 equals to what? It is the ratio of I2 upon V1. Here I2 is nothing but what the parameters belongs to port number 1, and V1 is nothing but the parameter belongs to port number, sorry, I2 is nothing but parameter belongs to port number 2, and its denominator is nothing but parameter belongs to port number 1. That's why this type of parameter can be called as a short circuited forward transfer admittance parameter. The name given to this Y21 is nothing but what? Short circuited. Why it is being called as a forward transfer? Because at its numerator we used to have the parameter belongs to output port, and at its denominator we are having the parameter belongs to input port. So output upon input, that's why it is being called as a forward transfer. If it is input to the output, that can be called as a reverse transfer. So after that, when we are putting this V1 equals to 0, at that time this equation number 1 will become what? I1 equals to Y12 times of V2, and equation number 2 will become what? I2 equals to, when V1 equals to 0, Y22 times of V2, Y22 times of V2. When we rearrange these two system equations in terms of Y12 and Y22, so Y12 is nothing but what? The ratio of I1 upon V2, I1 upon V2, and Y22 is nothing but what? The ratio of I2 upon V2. Both these two parameters are being tabulated by keeping V1 equals to 0. These two parameters are being tabulated by keeping V2 equals to 0. So as this Y12, it is the ratio of I1 to the V2. I1 is nothing but what? The parameter of first port, and V2 is nothing but what? The parameter of second port. That's why it is being called as a short circuited reverse transfer admittance parameters. What it is? The short circuited. Why it is being called as a short circuit? Because V1 is treated as a 0 when voltage equals to 0, so that can be called as a, that port is being short circuited. So it is short circuited reverse transfer, as it is the ratio of input to the output. Then last one is nothing but what? Y22, which exactly equals to I2 upon V2, so that can be called as a short circuited driving point output admittance. Why it is being called as a driving point? Because both these two parameters belongs to output port. So this is how these parameters are being tabulated in case of this admittance parameters Y11, Y12, Y21 and Y22. Then after that we need to determine these four parameters with the help of this network. Okay friends, welcome back. After tabulating all different four admittance parameter, now it's time to use these system equations on this given network. So as you can see, this is the pi type of network. So in this network, again there are two ports. This is the input port and this is the output port. V1 is nothing but the potential of input port, and V2 is nothing but what? The potential of output port. So here we need to determine these four system parameters Y11, Y21, Y12 and Y22. So how to do that? So for that purpose, what we need to do? We need to apply this Kirchhoff current law at these two particular node, right? This is nothing but what? The input port. That's why the potential which is present at that port is nothing but what? V1. This is nothing but what? The output port. So the potential which is present at that port is nothing but V2. So when we apply the Kirchhoff current law at that first node, whose potential is nothing but what here? V1. So as you can see, there are three currents belongs to three branches, 1, 2 and 3. So out of that three current, these two this I1 is incoming to that node, and these remaining two currents are nothing but what? The outgoing from that node. So according to this Kirchhoff current law, summation of incoming currents equals to outgoing current. So here I1 is nothing but what? Incoming currents. What about this particular current? The current flowing through this branch is nothing but what? It is V1 minus V2 upon 2. V1 minus V2 upon 2 plus, as far as this particular branch is concerned, according to that Ohm's law, I equals to V by R. So which potential we are having? V1 by 4 equals to 0. When we rearrange this equation, I1 equals to 1 half plus 1 by 4. There are two terms belongs to V1 minus V2 times of 1 half. We are having only one term belongs to V2. So if this LCM 1 by 2 plus 1 by 4, if the LCM is 4, so it is 2 plus 1, so 3 by 4. So I1 equals to 3 by 4 times of V1 minus 0.5 times of V2, or minus 1 half times of V2. So when we compare this system equation A with this equation number 1, so at that time we will come to know कि y11 equals to 3 by 4. Here I will write y11 equals to 3 by 4, and this system equation is what? Plus y12 into V2. Here the coefficient of V2 is nothing but what? 1 half along with this negative sign. So here I will write y12 equals to minus 1 by 2, and as it is the reciprocal of admittance, so the unit for this admittance will be mho, 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 right? So in same way we need to apply this Kirchhoff current law at this node number 2, right, which again consists of these three branches 1, 2 and 3. So out of that three branches, this current is incoming to this node, this current is also incoming to that node, and this is nothing but what? The outgoing current. So again one more time, summation of incoming equals to summation of outgoing current. So when we apply KCL at node V2, so the incoming current is nothing but what? V1 minus V2 by 2 plus this current is nothing but what? I2. The value of current itself is I2 equals to the outgoing current is nothing but what? V2 by 8. We are supposed to rearrange this equation in terms of I2. So I2 equals to this V1 will get shifted to the right hand side. That's why it will become minus 1 by 2 times of V1. This minus V2 by 2, it will become plus. So plus V2 into this 1 half plus 1 by 8. So 1 half plus 1 by 8, if LCM is 8, so it will become 4 plus 1, 5 by 8, right? So the equation number 2 will become here I2 equals to minus 1 half times of V1 plus 5 by 8 times of V2. So when we compare this equation number 2 or equation number capital B with equation number 2, so we are coming on to this conclusion here y21 is nothing but what? The coefficient of V1. So y21 equals to minus 1 by 2. The unit is nothing but what? Mho. And similarly y22 is nothing but what? The coefficient of V2. So here I will write y22 equals to 5 by 8 mho, right? So in this way, these impedance parameters have to be tabulated of that given network by using this Kirchhoff current law strategy, right? If we are having the T type of network, so in that T type of network we are supposed to use the Kirchhoff voltage law strategy. So I just hope we understand all those things belongs to this admittance parameters, or another name given to this admittance parameter is nothing but the short circuited parameters or the Y parameters. Thank you.